Okay, today let's start the difference between scalars and vectors. So, scalars and vectors. So, scalars are any physical quantities that has only magnitude, whereas vectors are any physical quantities that has both magnitude and what direction. So these are only what? These are only magnitude, but not what? But not direction. But not direction. Whereas these vectors are any physical quantities that has both magnitude and direction. So it has what? It has both magnitude and what? Magnitude and direction. Some example of scalars are what? That's speed. Examples are some examples of scalars are speed, time, mass. All these are what? Scalars. All these are scalars. And some examples of vectors are what? It is acceleration, velocity. Okay. Acceleration, velocity, and force. All these are what? These are some example of vectors. So, for example, let's say speed. Speed, how fast means it's the speed, and how fast and which side. This is what? A velocity, because what? It has both magnitude and what? Direction. How fast and which side, that means how fast is the magnitude and which side is what? The direction. So these are what? This is the velocity. Remember what's acceleration? Acceleration is what? It's a change of what? Change of velocity over what? Change of time. Okay, so this means v final minus what? V initial over what? Over t final minus t initial. This is the definition of acceleration. What about the velocity? The velocity is what? Velocity equals what? It is change of what? Change of displacement over what? Change of time. Okay, that means f final minus what? S initial over what? T final minus t initial. This is not the distance. This is the displacement, because distance is what? Distance is a scalar, and displacement is what? A vector. Why? Because it has both magnitude and direction. Okay, the next one, let us see how to add two vectors. Okay, addition of what? Addition of vectors. So, and addition of vectors and scalars. How to add two vectors? So remember, a vector has its own what? It is, for example, a vector has, it is an arrow. The arrow indicates what? It is the head or the direction of what? The vector, right? Therefore, example, when you add two vectors, if you are given two vectors or three vectors, so in order to add these two vectors, always we can connect the head of the first vector to the tail of what? The second vector. For example, let's say example one, if you are given, if you are given like vector A, let's say, or the first vector, okay, the first vector, let's say A, this is vector A, and if you are given the second vector, this is what? This is vector B, or we can say that this is the second vector, This is the second vector, or we can say vector B. So any vector has what? It is on tail end what? Head. This is what? This is the tail of the first vector, and this is the tail of what? The second vector, or vector B. And this is what? This is the head of the second vector. This is what? The head of the first vector, or vector A. So in order to add this vector A and vector B, always we can connect, or we can place the head of the first vector to the tail of the second vector. So which one is the head of the first vector? This is the head of the first vector, right? So we can say that. Sorry. Okay, so this is vector. This is vector what? This is vector A. These are the TA, means the tail of vector A. This is what? The head of what? The head of the vector A. So, and there's also what? There is the second vector. So this is the second. This is the second vector. This is the second vector B. So always the sum of the two vectors is, we can connect, it is, we can place the tail of the first vector to what? The head of the second vector. This is what? This is the head of what? The head of vector B. And this is what? The tail of what? The tail of vector B. This is the head of vector A. This is the tail of what? The tail of vector B. So we can the sum of these two vectors are, we can connect the tail of the first vector to the head of what? The second vector. Or the first vector is vector A, the second vector is what? Vector B. So this is what? This is the sum of two vectors, okay? This is the sum of two vectors. So this is what? This is vector A plus what? Vector B. This is the sum of, in order to find the sum of two vectors, always we can connect the tail of the first vector to the head of what? The second vector. Okay. So let's see example 2. Example 2. If you are given like the vector, which is like, remember in a polar or a plane, how many axes are there? They are what? Two axes. These are what? X and what? Y. Okay. Therefore, for example, if this is what? This is the y-axis, and always the vertical is the y-axis, the horizontal is what? The x-axis. In the polar, so there are two vectors. These are what? I and j vectors. The I vector is always located in the x-axis, and whereas the j vector is always located in what? In the y-axis. But in space, there are what? Three axes. These are what? X and Y and Z. So in space, there are what? Three vectors. These are what? I, J, and what? K vectors. So we'll see this one in the next one. Okay. So if you are given like a vector here, this is like a vector C. So a vector. So in order to find like theta or this vector or the resultant vector, remember that, for example, this vector is located 3 and what? 4. Because it is what? It is a plane, right? Because it's what? In a plane. How many axes? These are what? Two axes. This is x-axis and these are what? The y-axis. So let's say this one here. Let's use this one. Take out this triangle. This is what? A right angle triangle, right? This is a right angle triangle. What is this? It's 90 degrees. This one is 90 degrees. And what is this? This is what? This is theta, right? So, this is what? This is the y-axis. This is what? The x-axis. Here, the first one is what? The x-axis. So, this is what? This is 3. What about this one? This one is what? 4. This one is 4. So, in order to determine C, Okay, remember we can use what? Pythagoras theorem. So what the Pythagoras theorem says? The hypotenuse is equals what? The square root of what? The square root of x squared plus what? Y squared from here. This is the x-axis. So c equals what? Under radical of what? 3 squared plus what? 3 squared plus what? 4 squared. Okay? 3 squared plus 4 squared. And we can find also if you calculate the value of c or the hypotenuse, so we can find the value of what? Theta, right? So what's theta? We can use what? The trigonometry, okay? The trigonometry. Sine theta equals what? Opposite over what? Opposite over what? Over the hypotenuse. Okay? The hypotenuse. And cos theta is what? Cos theta equals what? Adjacent over what? Adjacent over the hypotenuse. Okay? The hypotenuse. So here, what is the opposite side of this angle? The opposite side of is 4, right? Or remember what's tan theta? Opposite over adjacent, right? Tan theta equals opposite over adjacent. Okay, so we can use either sine or cosine or tan theta. So if you know the value of c, you know the value of y and the value of y and x, they are given. So we can find the value of what? Cos theta. That means we can find the vector which is in the x-axis, and we can find the vector which is what? The y-axis, and we can find also what? The vector which is located in the hypotenuse direction. Okay, therefore in order to determine like the two vectors, so in a polar you can use what? A trigonometry. Okay, you can use what? A trigonometry. Okay, example 3. Okay, give two examples of scalars and vectors. This is also homework, okay? This is our homework. Okay, this is a homework. Please give two examples of scalars and vectors. So this is the end of today's lesson. In the next lesson, we will start how to add like two. If you are given two vectors in the polar and in a space, so please do this as a homework. So I will see you in the next video. Thank you. Bye.